Hello, and thank you for joining us for this Advanced Analytics webinar focusing on use cases for water and wastewater organizations. A few things to mention before we begin the use case demonstrations. Please submit your questions through the questions section of the GoToWebinar console. If we do not answer your question during the session, we will follow up with you afterwards. For any additional questions or inquiries, please email us at info@seek.com. Seek resources can be found on seek.com and on our community site, seek.org. Lastly, we will be participating in several upcoming industry events, and we encourage you to stop by and meet with our team. And with that, I will hand it off to our presenters, Joseph Gardner and Lindsay Wilcox.
Great. Good afternoon. Joe Gardner with Swan Black here. Just a quick introduction. Myself, I am the practice lead of a practice here called Swan Black. We're an analytics delivery services practice that, in partnership with Seek, deliver meaningful insight to industrial manufacturers. We've been around for we've been doing and working in industrial manufacturing for over 25 years, have a lot of experience in a various number of industries, for instance, CPG, food and beverage, water, wastewater, life sciences, chemicals, and power generation. By background, I have a master's degree in business analytics from the Kelley School of Business at Indiana. Went to undergrad at the University of Iowa and have been working in analytics for the better part of 7 years. So we are, as I mentioned, a Seek certified partner, and on my team we do have Seek certified users, certified analytics engineers, I should say, that are able to help our customers deliver meaningful insights from their process data. In partnership with Seek, like I mentioned, we do a number of different things. So, today our focus is obviously water, wastewater, some applications within Seek. But happy to answer any questions you guys have. I will also circle back at the end of the presentation here to answer any questions and provide some contact information. So with that, Lindsay, I'll kick it over to you.
Great. Thanks, Joe. So before we get started, a quick introduction of myself, my background, my experience. As mentioned, I'm an analytics engineer with Seek. In that role, I primarily work with customers across a wide range of industries, including the water industry, to leverage the analytical tools in Seek to get the most value out of their process data. Prior to joining Seek, I have experience working in the nuclear power industry at Westinghouse Electric Company, and most recently I spent several years working on the process control side of things, leading the field services team at a control loop performance monitoring software company, and that was again across a wide range of industry verticals, so a pretty diverse background. Today, we're going to start off by just diving right into the use case straight away. This use case will look at a water filtration system and discuss some of the background and regulatory reporting required for this particular site we worked with. Prior to joining Seek, the reporting and analytics performed were mostly done in Excel, so they were manual and very time intensive, so that might be a workflow that many of you are familiar with. So once we have a good feel for the starting point and kind of that underlying problem statement, we'll take a look at Seek, what it is, how it was used to automate and really expedite the reporting at this particular customer site. Finally, we'll dive into the demonstrations that are built out in Seek. I've broken the demo up into 2 sections. We'll first look at the analytics we performed on the water filtration system in Workbench, and then we'll look at building live reports and automated compliance reports based on those analytics and Organizer topic. There will be 2 question sections, one after each of these demos. So if you have any questions as I'm going through, please feel free to submit those during the WebEx chat feature. All right, so diving straight into our use case. Today, we're going to look at a use case that was developed working with one of our water customers. Specifically, this particular use case looks at a rapid sand filter system. So this system is part of the full treatment process, which removes contaminants from the raw water prior to being sent to the reservoir. So this is a cyclical process that has 4 stages that basically get cycled through, and those 4 stages you can see listed on the slide. So these 4 steps are really kind of the key or kind of the basis for the metrics that we'll be calculating or looking at today. So first we have the filter online stage. This is when the filter is actually running, it's in service, water is flowing through the sand to remove contaminants. The contaminants are basically being caught in aggregates. And typically a filter is online for about 50 to 100 hours or so before it enters the filter backwash step. In the filter backwash step, the filtration medium needs to be recharged. So this is done by reversing the flow through the sand to bring the sediments into suspension. Those suspended solids are then sent to the waste. So the process of removing the backwash water from the filtration system is our third stage that you see there, the filter to waste stage. And then finally, once the filter is recharged, is brought into a hold pattern. So it's basically just waiting to be brought back online. It's clean and ready for service. So what initially sparked our work with this particular customer looking at these filters was due to a certification report. So essentially they were required to generate this report to show that each filter was operating in compliance with established best practices. And those best practices were defined by the state regulatory agency. So not only were they looking to kind of generate this report to show that they were in compliance, but they also wanted an internal way to give staff a method to actually compare how their system was performing over time from 1 month to the next, for example. So what you're seeing on the screen is a quick look at what that report actually looks like. The figure you see is an example turbidity profile. And we're going to be looking at turbidity a lot today. So essentially turbidity is the measurement of the amount of suspended solids in the water. So it's the cloudiness or the haziness of the water. And there's several key things that are shown in that chart that are kind of key to creating or mimicking this report in Seek that we need to be able to include in our final report. So you see that the 4 different modes of operation are online, backwash, filter to waste, and then the back online stage. They're all kind of marked out on that trend. So being able to show when the process is operating in certain modes or certain stages is a key requirement to this report. Additionally, we needed a way to identify whether or not the filters were meeting those certification goals or requirements. And we can see those goals listed on the right of the trend. So these are just kind of some of the basics requirements that we need to be able to include in that final report. So for this particular report, the customer was required to include 1 graph, which we just saw, and the analytics for those 5 requirements per filter, per quarter, for 4 years. And with 16 filters at this facility, you can see how the number of graphs and analytics required really starts to kind of explode. So the original workflow for this, for generating this report, involved manually creating each of those graphs in Excel. However, you can imagine just how much time this required to not only export the data, but do things like data cleansing and contextualizing the data, identifying when the process was operating in each of those stages we talked about. All of this resulted in the reports taking a lot of time to complete, so that by the time the report was finished, it was actually already outdated by however long it had taken to put the graphs and analytics together. So even if that report had some sort of insight, the opportunity to make adjustments to operations may have already passed. So this is where Seek comes in, essentially as a solution to this issue of the time intensity of generating this reports that was just described. With Seek, you're able to build out these reports and trends, apply them across similar assets, which are the filters in this example. And not only that, but the trends and analytics can auto-update so that as the process continues to operate and more data is becoming available, you don't need to repeat the full process of generating that analysis. It's just automatically updating in near real time as the new data becomes available. So what exactly is Seek? Seek is a browser-based, self-service analytics solution that's designed specifically for time series data analytics. So there are 2 main applications available within Seek, and we'll take a look at both of these today. There's the Workbench Analysis and then the Organizer topic. In Workbench, there are hundreds of tools and capabilities that are available to the user, from flexible trending, data cleansing method, math functions, basic calculus functions like taking the derivative or integral of a signal, to more advanced functionality related to machine learning and pattern recognition. In Organizer, users can create reports that summarize the results of their analysis create updating dashboards for display in the control room. The application server for Seek is installed somewhere that can access and connect to all of your time series data sources. So whether this service is on-premise or in the cloud, the Seek server provides all application features in a manner that is not only reliable, but also scalable. So whatever the size of your team, Seek can be scaled to appropriately meet the needs. Seek also connects to all major data historians, SQL databases, and whatever time series database you may be using. Data can also be imported from standalone CSV files as well. So all of this is just to say that wherever you are storing your data, or if you are using multiple data storage locations, maybe you have more than one historian with some lab data in a CSV file, all of that can be imported into Seek so that it's all there in one central location, and all of that data from different sources can be analyzed together. You can also export data out of Seek into applications like Excel, PowerPoint, and actually any OData client such as Tableau or Power BI. And finally, Seek really requires minimal IT effort and is often set up in less than an hour. Obviously, this depends on your tag count and the number of data sources you'd like to connect to, but the time required for installation and configuration for Seek is really quite minimal. So what is the breadth of questions that people use our software to address? We have customers from all process industries. This includes not only water and wastewater, but also oil and gas, chemicals, utilities, mining, pharmaceuticals, food and bev, you name it. Our process manufacturing customers rely on Seek for a wide variety of analytic types, many of which you see listed on the screen. So while we're not changing the native data, Seek takes those signals, cleanses the data for analysis, dealing with issues that you're probably common with or probably familiar with dealing with in process data, things like discontinuities, noise, gaps, drops, and other types of anomalies. There's a full suite of modeling tools which allows you to extrapolate future performance and project when maintenance will need to be performed on or how the system might react to different set point changes. And finally, there's a bunch of friendly point-and-click tools that allow users to perform ad hoc analysis and search the document the root cause of various process disruptions. So one last thing before we jump into our first demonstration that I just want to discuss is kind of key to Seek. It's the idea of conditions and capsules. So this is a key item or functionality that makes this particular water filtration use case so easy and scalable in Seek. Essentially what a condition is it's a time period of interest. Every instance where that condition is true is called a capsule. So the idea of capsules and conditions is a key fundamental piece to any user's experience in Seek. There are several different methods that you can use to identify and define and create these conditions, a few of which are listed on the screen. Looking at that top example, we can see that we can define a condition based on time. So maybe we want to perform analytics on a time period like every Monday. So each yellow bar that you see along the top of that trend corresponds with operation on a Monday in this example. So in Seek, there would be a condition called Mondays. Each occurrence of Monday is represented as a capsule. A condition may be defined as a limit. So maybe you want to create a capsule every time your signal exceeds a turbidity limit, for example. Or maybe you want to define a condition based on a certain shape or pattern in the signal, like we see in the bottom condition. These are just a few examples. There are other methods, other more complex methods for defining conditions and capsules, including doing things like actually importing those conditions from some sort of external database like SQL. But really the magic in these capsules and conditions is in our ability to combine them. So very rarely is a single condition by itself of much interest. Rather, we want to know when multiple conditions are occurring at the same time. So within Seek, there are multiple different paths of logic you can use between your conditions, such as and, or, join, inside, outside, to create greater insight across conditions and signals. And once you've defined your conditions and composite conditions, you can then use Seek to perform calculations on each of those time periods of interest or capsules. So you can create new signals showing averages, total power, or volume through integration, or rate of change through signal derivatives. Or for this example, we will take a look at the total amount of time the process was operating in a poor condition per cycle. So hopefully that's enough background, and we'll switch gears a little bit and switch into our first use case. Okay, so right now we are starting on the Seek homepage. You can see a listing of some analyses and topics that I've already created. One of the great things about Seek is that with any content I create, it can be easily shared with and collaborated on with any of my colleagues. So we're going to take a look at this first analysis I've created listed on the top here. So right now we're on the Gather Process Data tab of my Workbench Analysis. I have a blank screen, so obviously the first thing I want to do is find the data tags that I would like to include in my analysis. Seek leverages a live connection to whichever historian or historians you may be using. So whether that's one historian or multiple historians, all of that data is available to you within Seek. There are a few ways that we can search for and find data tags within Seek. The first option, simply type in the name of a tag, and Seek queries all connected data historians to search for that tag. Alternatively, if you use any sort of asset structure such as PyAsset Framework, or you can even build that structure out within Seek, you can use that to navigate through your tree as I'm doing here. I'm actually going to drill down to filter 1 and then select the tags for the signals that I'd like to include in my analysis. So notice as I'm selecting each of these tags, the signal is trended over on the right. So these tags are what we'll be using in our analysis here. We have a turbidity, head loss, and then a mode tag, which tells us the stage the process is operating in by reporting a 1, 2, 3, or 4. So this mode tag is going to be the starting point as we start to contextualize the data. So let's define our filtration cycles and add some context to the data. So switching over to our define filtrations cycles worksheet, we're going to add context to the data, and I can conveniently use that mode tag to create a condition for each of the stages in my filtration cycles. So let's start with the filter online stage. We can create this condition using the value search tool. I first need to give my new condition a name, and then I want to search that mode tag we just talked about and identify any time that that mode tag is equal to 2. A value of 2 indicates that we're in the filter online stage. So when I execute this value search, you should see that we now have bars or capsules that appear along the top of my trend. Each of these capsules represents a time period when the process is in the filter online stage. We can repeat this process of doing a value search to create a condition for each stage in my process for each of the other stages. In this case, I've already gotten a head start on the analysis and documented my steps in the Journal tab. Journal is a place where users can document their analysis right alongside where they're creating it. So not only can we add text, images, tables to the journal, but users can also add links to certain views, signals, or conditions. So in this particular journal, I already have links created for the backwash, filter to waste, and filter online stage conditions. So all I need to do is actually just click on these links. And as I click on those links, you'll see the conditions added to the trend. And these conditions were created using value search for the other stages in my process. Okay, so we now have a condition for each stage in the cycle. Now what I want to do is create a new condition that defines the whole cycle from start to finish. This is accomplished in the Composite Condition tool. This tool allows you to select from a wide range of different logic to combine conditions. I'm again going to give this new condition a name of total cycle. And next I want to select the first stage, my filter online condition, and the last stage, the filter offline condition. And then I'm going to use the join logic to create a new condition for that full filtration cycle. When I click execute, this is going to result in the pink capsules we now see. And if I select these individually, you can see each pink capsule highlights an individual cycle. Okay, so we've added some context to our data using conditions. We have the basic framework, but what we really want to do is define the analytics for each of the goals that we talked about in the PowerPoint. So switching to our next worksheet, we can see our first goal described in Journal here states that the turbidity should be less than 0.1 NTU 95% of the time while the filter is online. Essentially, we need to execute the equation listed at the top of the journal which is based on the duration of the filter on line and the duration of the turbidity that greater than 0.1 per cycle. So the first thing we want to do is just identify every time the turbidity is greater than 0.1. So again, we're going to use value search to find those time periods. So here I'm searching the turbidity signal and I'm getting a capsule every time my turbidity is greater than 0.1. However, I don't actually care about every occurrence of this condition. I only care about when my turbidity is greater than 0.1 and my process is in the filter online stage. So let's use the Composite Condition tool and to define the new condition when both of these input conditions occur at the same time. So that's going to be the intersection logic. Now we can use the signal from condition tool to calculate the duration of these capsules during each cycle. I first need to give my new signal a name. I'd like to calculate the total duration in minutes of the turbidity condition per cycle. I can then specify additional information or inputs to adjust how this new signal is going to be displayed on the screen. When I click execute, we'll see a new time series signal appear or be created that reports the total time above the 0.1 threshold per cycle. So this is just one of the two inputs required for the equation defined in journal. We'll again use signal from condition to calculate the total filter online duration per cycle. Many of the inputs here will be the same as the tool we just execute, except here we're looking at the filter online condition duration as opposed to the time we're above a threshold. So executing this, we will again get a second time series signal, which is now telling us the total time the filter is online per cycle. So we now have our two inputs to that equation, and so we can actually calculate the percentage of time the turbidity is greater than 0.1 while the filter is online per cycle. While we do have an extensive list of tools available in the tool menu, we realized it would not be possible to create an individual point-and-click tool for every possible type of analytics our users may be interested in. To support these different and use case specific analytics, the formula tool can be leveraged. In Formula Tool, users have access to an extensive library of operators and functions, and it's also where users can perform basic math operations. So here we need to perform the math operation that we defined in journal. So like all of my other tools, I'm giving my formula a name, and I just pasted in that formula that we looked at in journal. I'm then need to name each of the variables. So these are my two input signals that we just calculated. And I'm giving these variable names to be consistent with the variable names in the formula from journal. So clicking execute here is going to result in yet another time series signal. This one's reporting that final KPI or that final metric, which is the percentage of time the turbidity is greater than 0.1 per cycle. So this signal is interesting to look at on a trend. However, we also have the option to view these results in a table view or what we call a scorecard. So using my link in journal, we can see the scorecard that I've already pre-created. So each column in the scorecard represents a separate filtration cycle, and I'm getting the calculated metric or KPI value for each of those cycles that we see listed here. So this is just one goal that we were looking at, but if you remember, there were several different goals that we can all include in one scorecard for inclusion in one report. So here we have a larger scorecard with each of these goals listed. Notice we've now included some color coding, which tells me or gives me an indication of where the values are in relation to the metric limits. It tells me whether it's met the goal or not. So this scorecard is a great quick way to look at large time periods, a month, 2 months, 6 months, for example, and get all of that insight and value out of the squiggly lines on the trend. So the final piece here is that we've built this analysis for one filter, but obviously we need to perform this same report and analysis for all of the other filters at this site as well. So within Seek, we have the functionality called asset swapping, which allows users to quickly apply a set of analytics from one asset to another similar asset. So with just the click of the button, like I'm doing here, we can quickly apply all of the calculations we created for filter 1 to any of the other filters listed in my asset tree. So just a quick summary of the analysis we just created. We found all of our data tags needed for the analysis. That was our first quick and easy step. And then we created the framework or the foundation for that analysis by adding context using the value search tool to create a condition for each stage in the filtration cycle. We then combined those conditions using the Composite Condition tool to create a condition for the full cycle from filter online to filter offline. Once we had contextualized the data, we used the signal from condition and formula tools to calculate our performance metrics or KPIs. The results of these calculations could then be viewed in a trend over time or in a tabular view using Scorecard. Finally, we were able to scale the results of our analysis to other similar filters by using the asset swapping functionality. And with that, that brings us to our first questions section. So I guess I will turn it over to Elise to see if any questions have come in so far.
Great. Yes, we do have 2 questions that have come in so far. And again, you can submit those questions through the questions section of the GoToWebinar console. First question, can you perform this analysis if you don't have a mode of operation tag?
That is a great question. So as we saw in the analysis that we just completed, we had a mode tag that was a really easy and simple way to just identify which of the 4 stages we were operating in. However, that tag isn't always available, or maybe it's not something that's stored in the historian. So if a mode tag is not available, we absolutely can still perform the analysis in Seek. We would just need to identify the different stages using a different method. So we could do things like identify when the flow through the filter is positive or greater than 0. That's going to tell me I'm in the filter online stage. Or we could use value search to identify when the backwash flow is above 0, telling me I'm in the backwash stage, or when the flow is equal to 0, that tells me I'm offline. So there are other methods that we can use to define those different stages as well.
Excellent. The next question, in the demo, we created an analysis based on historical data. Is it possible to have the analysis automatically update as new data becomes available?
Absolutely. So one thing that we didn't point out when we were in the demonstration is that with On the Trend, there is a auto update button, which allows you to update the analysis in near real time. So what that means is that as new data becomes available in the historian, Seek is pulling that data into Seek and applying all of those analytics and trends and visualizations that we created to that new data as well. So we can do that both within Workbench Analysis and also Organizer Topic, which we'll take a look at in just a bit here.
Wonderful. That concludes the section of questions right now. We can continue with the next use case.
Great, thank you. Okay. So we just finished walking through the first part of our demonstration where we looked at Workbench Analysis. Now we're going to dive into Organizer Topic. So we're going to take a look at how this application can be used to build live dashboards and automated compliance reports. And again, if you have any questions as I'm going through here, please feel free to submit them via the chat function. We will have another question and answer session after this second demo. So we built out a detailed report with different views in Workbench Analysis, but now I want to be able to create that final report that we talked about for the compliance reporting, or maybe a dashboard that I could share with operators in that live updates in the control room. This is where Organizer Topic comes in. Seek Organizer is really the interface that our users typically use to digest the results of a particular analysis. So when we create a custom report that summarizes the performance of all of my filters in a central location, that's what can be done in Organizer Topic. Or maybe I want to create an updating dashboard that's displayed in the control room for use by the operators. That's going to tell them in near real time how those filters are performing. So we'll take a look at kind of the 2 different views that can be created within Organizer Topic. So let's jump into the demo. So what you're looking at right now is an Organizer Topic. As I mentioned, any of those charts we created can be used within Organizer to turn into a live updating dashboard or report. To add content to the Organizer Topic, it's actually really simple. So we're going to click on this Insert Content link at the top, and we're going to navigate. From here, we can navigate down to any analysis. We're going to drill down in this case to that water filtration analysis we just created. And I'm going to select, once I'm in there, I'm going to select the worksheet I want to include, in this case, we're just going to select the raw data tag worksheet. Here it's going to ask us some questions about how we'd like to turn that graph into a live updating screen in our organizer topic. So stuff like number of pixels, shape, but most importantly down here at the bottom, each piece of content can have its own templatized date range, or you can have many pieces of content tied to one identical date range. So we're very quickly able to insert any of those charts we built in Workbench Analysis and apply to the desired date range. So I'm scrolling down here, we can see some other pieces of Seek content that that we didn't have a chance to look at in Workbench Analysis. Here we see a tree map, which gives a high-level overview of how our assets are performing. So you could use that to indicate which of the filters are not meeting goals. Or if you want to have live updating screenshots, you can create live updating dashboards. So this trend that I'm looking at now is just showing the last 30 minutes of data. So you can specify both a window size, 30 minutes, and an update rate. In this case, for that particular image, it's set to update every 5 seconds. So as I'm talking here, you may see some of the different figures or trends or scorecards update. So how do we take these topics and apply them to the filter goals we were just looking at in our use case? So I'm going to switch to the next topic here, the next worksheet, which is a great example of how we can take a look at our whole fleet of filters in a single view. So now instead of hitting that asset swap button that we did in Workbench Analysis, I can quickly get information about how any of my filters are performing over any time range within a single report. So right now we're looking at the performance of each filter's cycles over a period of 14 days. So the number of cycles each filter ran during that time period will impact the number of columns we see in the scorecards. And say I'd like to move this report to a different date range. All I have to do is just enter that date range and it's automatically applied to all of the graphics in my topic. So we can see how this report looks for a totally different time period. And if there are operator comments that may explain why we're getting goal violations, the operators can just come in here and add whatever text or explanation to the topic since it is a living document. Or maybe we want to add screenshots from a SCADA system that help explain anomalies. We can add those screenshots or those images here as well. All of these edits and changes are also recorded. So in that way, it's a lot like Google Docs. We can see all of the different versions of this topic over time, and we can actually even revert to a previous version as well. So this topic is a great example of a live dashboard that we could use for monitoring. So as each filter enters a new filtration cycle, we would see that cycle pop up in the topic as a new column in Scorecard. And in some instances, maybe if you're an operator, you'd like to dive deeper into the results. Maybe you see one of these red cells pop up to indicate a goal violation. You can actually just click on the scorecard to navigate to the view-only mode of that analysis. The view-only mode allows you to interact with the analytics without actually changing the analytics or the math behind it. So if I click on that red cell where we had the violation, it's going to take me to the exact time range. And looking at the trend will be able to give me some additional insight. And I can very quickly see that we had that goal violation because there's actually a spike in my turbidity here that caused me to violate the goal we originally saw in organizer topic. So this first example, we looked at a live updating dashboard, but that second alternative view that we were interested in, we wanted to create that compliance report to identify whether or not we're meeting our goals or requirements. So right now, what you're looking at in this particular topic, at the top, we have a scorecard that shows all of our goals, and then we have a turbidity profile trend similar to the one we saw in PowerPoint. Next, and we're clearly marking each stage in our cycle here, like that trend did as well. Next, we have some additional information on exactly when the backwash started, when the filter to waste started, the total duration of each of those stages as well. So to publish this particular report, I can quickly turn the organizer topic into a PDF. So this PDF can be used in any way that you're already familiar with. It can be saved, attached to an email, or included as part of some larger report. So we started off by just looking at a very specific set of goals, those 5 goals that we saw originally listed in PowerPoint. But once we have the framework for the analysis in place, the framework being those underlying conditions and capsules, we can use all of that framework or the basis to apply a different set of more advanced analytics that may give us deeper insights into how the process is working. So here we've taken the framework where we added context to the data, and we can use that and those underlying conditions to calculate things like the total clean flow, the total backwash flow, or the ratio of the clean flow to the backwash flow. This scorecard lists some additional metrics that we have calculated for the filter, and we can even take a look at more complex metrics such as the average rate of head increase. That framework can also be used to create additional visualizations. So here we have a trend on the bottom that's looking at the cycles over 14 days and overlying those cycles in relative time. So this is a powerful method to visually compare how each filter cycle compares to the other filter cycles. In this case, we can actually see that later in the week, the head loss is rising at a much more gradual rate than it was earlier in the week. So we can gain some interesting insights from these additional visualizations as well. And finally, there may be a need for more annualized reporting that shows how these filters are operating over a larger time period, like a year, for example. So in the last topic, in this last topic, we're looking at a much larger time period. Here we can do things like compare performance in 1 month to another month. We can include higher level annual summaries for things like the performance curve of how the average head increase relates to filter online time. So hopefully in the different examples we've walked through here, the different organizer topics we've taken a look at, you've gotten a feel for the different options or the different options that you can develop with an organizer topic, the interesting analytics and the different views for whatever that audience is. So whether it's a high-level management view for a compliance or regulatory reporting, or whether it's a more detailed cycle-specific view for operators, there's a lot of flexibility in organizer topic to create either of those views. So there were some key parts or methods we used in this analysis that made the final report so successful. The first was in our use of conditions and scorecards. Using a condition to define the total cycle and then displaying each capsule in that condition as a separate column on our scorecard, complete with color coding to indicate how each value corresponded with its limit, made it really easy to digest large amounts of data over big time periods relatively quickly. Next, our use of an asset tree enabled us to leverage Seek's asset swapping capability so that we only needed to build each set of analytics one time and simply apply those analytics to all of our other filters with just the click of a button. And finally, all of these analytics were pulled together and summarized in Organizer Topic. We looked at several different views in Organizer Topic. One view looking at a shorter time period with live updates, maybe for display in a control room for use by operators. Another view looking at longer time periods, a year, for example, that provided a high-level overview for management. And so that brings us to our second and last questions session. So we'll see if Elise, any more questions have come in?
Yes, we did have a couple more questions. The first is, what are the next steps in more advanced analytics available for this or a similar process?
Yeah, so there's a lot of different options for how we can kind of continue to build out this analysis. Something that might be interesting is we can integrate weather data. So with one of our recent releases of Seek, we have included a new capability to connect to the NOAA weather connector data. So we could bring in that weather data and include that in our analysis to maybe include predictions of future weather forecasts, use that to project filter runtimes in the future going forward. So that's just one example of some additional analytics we could do.
Great. And then the next question, who should I contact to learn more about Seek's capabilities?
That is a great question, and that's actually on our last slide here. So if you have any questions about Seek, feel free to reach out to info@seek.com, and then Joe's contact information is also on the slide as well. And with that, I might toss it back over to Joe to kind of close out, unless there were any more questions, Elise.
Nope, that wraps up the questions.
Okay, great.
Great, thank you, Lindsay, and thanks, Elise, for this session. Thought everything went very well. So yes, if you guys have any questions, please don't hesitate to reach out. My contact information is here. You can also find us on LinkedIn under Swan Black. So please, if you have any questions, don't hesitate to reach out on a number of different issues, whether that's anything that Lindsay walked through today, or if you guys have a potential application that you just want to validate whether or not it's something that might work within Seek. So like I said, the contact information here, and please don't hesitate to reach out. Thanks very much. Thank you, Lindsay. Really appreciate it.
Great. Thanks, everyone.